Now let us understand some interesting scenarios for overriding. Suppose we have a tiger object, tiger t is equal to new tiger. At this time what will happen? A tiger object will be created in the heap, and this t will point to this tiger object. But remember what I had told you, that this will have its parent class portion also, that is animal portion here, and since this animal automatically inherits from automatically inherits from object class, so object portion will be also available to this tiger object. Okay, now what will happen if I write t dot? Now what will happen if we write t dot? What methods are going, what behaviors are going to available to this tiger object? For now, think of this eat method, that this eat method is not defined for now. For now, there is no eat method in the tiger class. Then eat, sleep, walk, these methods are already available to tiger. Okay, all the methods of animal class, that is all the behavior of animal is available to this, plus all the behavior of the object is available to this t reference. Okay, I think till now you are clear. Now suppose we write the eat method, that is tiger redefines eat method, inherited method from the animal, and it redefines it its own way. That is, it says that I do not eat grass, I eat stacked flesh. So what will happen at this time? That is, what will happen when we call t dot eat? What will happen when we call t dot eat? Will this method will be called, or this method, that is method from the animal, that is parent, or method from the child will be called? What do you think? Here we can write as this object has all the methods, 9, 11, 10, 11 methods. This is object, this is animal, and this is our whole tiger object. So eat, sleep, and walk are available to this, plus all object methods are available. But what happens? This eat method is redefined here in the tiger class. So what will happen at this time when we write t dot eat? Which will call? So which will be called? So let me tell you, friends, here comes the role of compiler and the role of JVM. Two important things, that is compiler and JVM. So what is the role of this compiler and what is the role of JVM here? When we call t dot eat, then we are having two methods. One method is available from eat, that is here you can see, and another method that is rewritten by the eat method. Here it says that I do not eat grass, I don't eat grass, and here it says I eat grass. So it says I don't eat grass. So which method will be called is decided by here, JVM. Okay, so let me tell you about the role of compiler and JVM. When we write tiger t is equal to new tiger, then what will happen? The same thing, our object of tiger will be created. And when we write t dot eat, at this time what happens? Compiler here, compiler will check for the eat method. Okay, eat method, and where will it see? It will see the reference class. What is the reference class? Here you can see tiger t. Okay, So reference is T, that is tiger type. So in the tiger class, it will compiler will look if there is each method. So in the tiger class, here you can see we have each method. So simply it will compile, find the role of compiler is over. Compiler simply checks if this method which is being called is present in the class or not. If it is not present, it will give compilation error. The code will not compile fine. Now think of the role played by JVM. What is the role of JVM? The role of JVM is to call the method based on the runtime object. Here whose object is created? You can see here new tiger, that is tiger object is created. So what will JVM do? JVM will simply call the method based on the runtime object. Here runtime object, you can see runtime object. JVM will call the method based on the runtime object, that is method resolution is based on the runtime object. So what will happen? Here we have tiger object. So what will happen? The each method from the tiger will be called. Simple. What does compiler do? Compiler simply checks if this each method which is being called is present in this reference type. This T is of reference tiger. So if this each method is present in this reference type or not. So here you can see the tiger class contains each method. If this each method is not there, and also it is not inherited from the animal, then it will show a compilation error. So this is the role of compiler, that is simply checks if the method being called is present in the reference type or not. And what the role of JVM? JVM decides which method is to be called based on the runtime object. That is, here runtime object is of tiger. So the each method here, this each method will be called based on the runtime object. Here it is tiger, so it will be called from the tiger class. Now think of some other scenarios. And think of some other scenarios. The previous one was, let me write it first, tiger E is equal to new tiger. So in this case, when I call t dot eat, what happened? The eat method from the tiger class was called. When the second scenario is when we write animal is equal to new animal, and then I call animal dot eat. Then what will happen here? The same concept. First of all, what will compiler do? Compiler will check for this. A new object, animal object is created in the heap here. Animal dot eat is being called. So simply compiler will see if this eat is present in this animal class, that is reference type, that is animal class or not. So here you can see eat method is present. So compiler will not give any compilation error. Now which method will be called? Will the subclass, the method eat method from the tiger, that is subclass, that is tiger, will be called, or the method from the animal will be called? So this is decided by the JVM. The same thing as earlier. This will be decided by JVM. So here the runtime object is of animal type. So simply the method from the animal will be called. That is, method resolution is done by runtime object. So each method from the animal class will be called. So what will be its output? Simply the I eat grass as defined earlier in the animal class. Okay. And now think of an interesting scenario also. Here we have animal reference, that is A is equal to new tiger. What will happen at this line if I write A dot eat? Okay, what happens at this line? This line also behaves like the previous one. That is, first of all, what compiler will do? Compiler will check for each method in the defined reference type. That is, it is of type animal. So it will go and see for animal in the each method in the animal class. That is, there is present each method is present in the animal class. So it will compile fine. There is no problem. If each method is not declared in the animal class, then simply it will show compilation error. Okay. So the job of compiler is done. It simply looks for each method in the animal class and it is present there. So compiler will compile fine. Now, which each method will be called here? A dot each. Here the same thing. Method regulation will be done based on the object, that is runtime object. So here each method, here runtime object is tiger. So this method, that is this each method, will be called here. And also suppose think of a scenario, that is we have another last scenario, that is tiger t is equal to new animal. Can we assign a child to its parent object? Will it compile fine? So simply let me tell you, this will not work. Okay. Method overriding is called as runtime polymorphism. Why? Because method resolution is always done based on the runtime object, not at the compile time. So this method overriding is also known as runtime polymorphism or late binding. Many terms are there. So simply remember it as runtime polymorphism.
So friends, theory is over. Now let's implement the theory here. So here you can see I have animal class, and in this we have eat method and is printing I eat class. And in tiger I am overriding this eat method, and you can see here I don't eat grass is sage, and I eat stack by killing him. Okay, and it is extending animal. Now let's see what happens when we write t equal to new tiger t dot eat. Okay, so we are calling t dot eat method. So as we saw in the theory, it should call eat method from the tiger class. Okay, so let's see if it is calling from the tiger or not. Yes, you can see here it says I don't eat grass, I eat grass tag by killing him, and this statement is in the tiger class. Okay, now let's see for animal. Animal is equal to new animal. So this animal dot eat should call from the previous one, that is eat class, that is animal class. Okay, so let's run and see this. The second line of output should be from the animal. Okay, so yes, you can see here this I eat grass, and this is called from the animal. Here you can see in the animal I eat grass, eat method is here, it says I eat grass. Okay, now let's see our third interesting scenario, which was animal a is equal to new tower and t dot eat. Now this eat method should be called on the basis of this runtime object, that is tiger here. So eat method from the tiger should be called here. Okay, so let's run it. And see what happens. Yes, you can see the third output, that is this third println t dot eat is called from the tiger. So I think you are clear with these three conditions. And now let's see the fourth condition, the fourth scenario. Tiger c is equal to new animal. Then you can see what it says. It says change type of c to animal or add class to tiger. So you can see here the compilation error. It says type mismatch, cannot convert from animal to tiger. Okay, so this we cannot store animal, that is parent object, to child reference. I think you are clear now. Okay, that's all friends. Thank you.